Okay, class, we're going to be graphing absolute value inequalities, which is very close to what we have been doing recently with absolute value equations. So the first one up is we're going to graph y is greater than or equal to 3 times the absolute value of x. Remember that we have this form from absolute value equations where you would look at the h and the k value to see where the vertex translates from the origin. So if it starts here at the origin, this is a left or right move. We don't have anything there. This h is 0. And this is an up or down move. We don't have a k there. So it moves left or right 0 and up or down 0. So the vertex of our new graph is still at the origin. Then you look at the a value. The a value is 3. And on one side it acts like the slope, so I have a rise of 3 and a run of 1 from this point to the next, and then I'm going to continue that pattern until I run out of room. Up 3 over 1, that's enough on that side, and then we're going to go to the other side. It is going to reflect over this axis of symmetry right here, and there's my graph with only points and no lines, so let's put those lines in. Here's one side, and there's the other. Okay, so what I've graphed now is y equals 3 times the absolute value of x, not 3 is greater than or equal to 3 times the absolute value of x. Well, the difference between them is that we have regions. This region here you might consider inside the absolute value, and then the other region is going to be outside the absolute value, and that's going to be everything else. So all this space down here, and even though it looks like this is the smaller region, just imagine it opens wider and wider as it moves up. Okay, so one of those two regions is the answer. So I'm either going to be shading inside the absolute value or outside. Well, which one is it? In order to answer that question, I'm going to pick a point anywhere. And I'm going to try and make it nice and convenient, like right here. This is the point 0, 10. I want to see if it is a solution to this. So I'm going to plug in x equals 0 here, y equals 10 there, and see if I get a true statement or a false statement. I know that's kind of hard to read, but this is the absolute value of 0. That's 0. 3 times 0 is 0, so this becomes 10 is greater than or equal to 0. And that's true. 10 is greater than 0, so it's greater than or equal to 0. So since this point that I picked was a solution, I got a true statement, this is my answer. The yellow region is my answer. So I could, if I wanted to, erase all of the green stuff. And I've got my answer. It's the shaded region right here. Okay, here's another one. We are going to take the point that would start at the origin. We are going to move it 4. Which direction? It says plus 4, but the form says minus. So we're going to do the opposite of what it says here. We're going to do the same as what it says here, which is we're going to go down 2. It opens up. It has a slope in one direction of 1/2. So I'm going to get a bunch of points. And some on the other side. And then test a point in either region. It doesn't matter which point you pick, but try to make it as simple as possible. So let's suppose I pick that point right there. That's the point 0, 5. And we plug in x equals 0. And we plug in y equals 5, and we see if we get a true statement or a false statement. Absolute value of 0 plus 4 is the absolute value of 4, which is 4. 4 times 1/2 is 2. 2 minus 2 is 0. So this evaluates to become 5 is less than or equal to 0. And that is false. So this point is not in the region that is the solution. So my solution is the outside. And there's my answer. Okay, another one. We have a point at positive 5, positive 2, and it's my vertex, so that's here. I have a slope that acts like 2 in one direction. That's rise 2, run 1. It is a positive slope. It opens up. So far I've had all positive slopes. That's going to change pretty soon. Check any point you want. Make sure it's not on the line. We don't want to be bothered by on the line. Let's see. Let's do the origin. That's nice and easy. This point right there, we're going to plug in 0, 0 and see if we get a true statement or a false statement. So I evaluate the number inside the absolute value. That's negative 5. The absolute value of negative 5 is 5. 2 times 5 is 10. 10 plus 2 is 12. So 0 is greater than or equal to 12. That is false. So the region where I picked my point, which was outside of the absolute value, was not a solution. So that means inside the absolute value is the solution. Okay, take a minute and try this. Come back and see how you did. Notice that we have an absolute value of a negative. The a value is negative, so it opens down. Okay, here's the graph that I have. It has a vertex at positive 3, negative 3. So shift 3 to the right, 3 down. It has an a value that's negative, so it opens down, and a slope like a positive 1 in one direction and a negative 1 in the other direction. Then I pick a point, I pick the origin, and you see if it is a true statement or a false statement, and it is a false statement. 0 is not less than or equal to what I get out of here. Here's a sneak peek of some of the calculation. When I put in 0 there, it's just 0. When I put in 0 here, 0 minus negative 3 is negative 3. Take the absolute value of negative 3. It comes out as a 3, but there's a negative waiting for it. So I get negative 3 minus 3 is negative 6. So it becomes, is 0 less than or equal to negative 6? And the answer is no. 0 is greater than negative 6. So the region, which is outside the absolute value, where I picked my point, the origin, it gives me a false statement. So the other region inside the absolute value is the solution. Okay, this is the last one that isn't a you try it. And the question is, how is this different? Can you tell? Well, one thing is different is it doesn't have an equal to sign under here. So you can go ahead and try this. I'll pause the video and then I'll show you what's different. Okay, can you see what's different? Because I had no equal to sign underneath the inequality, the boundary line, which would be the part that was the two lines that made up the V shape, the boundary line is dotted. It means that's not a solution. It's non-inclusive. So, for instance, if I was checking the vertex, I would get a false statement. The vertex is the point 0, negative 1. And if I check 0, negative 1 to this inequality, the negative 1 is my y. And I'd have 0 times 5 halves is 0, and then minus 1. So is it true that negative 1 is greater than negative 1? No, it's not. If you had the inequality in there, if it was originally in there, negative 1 greater than or equal to negative 1 is true because of the equal part. So now that the inequality is non-inclusive, you need a convention to show that the boundary lines are not actually included. We make the lines dotted. So look out for that. If there's non-inclusive inequalities, dot the boundary lines. Okay, try this. Alright, here's what I have so far. I have a little blank here, question mark. What's the inequality going to be? So I'm going to erase that. Get my pen ready. So the rest of it you should have, hopefully. It opens down, so you got a negative a value. It also has a slope of 1 in one direction. Off by a little bit here. It's a cumulative mistake, so It should be here, 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 should be there. So my line isn't very accurate in this direction. Looks pretty good. Okay, the vertex shifts left 2, so that's a positive 2 for an h value. It goes minus a negative 2. And then your k value, it goes up 3. So which one of the inequalities is this? Well, you could always try one of them and see if you get a true statement. So I already know that one of these points is graphed. So here, let's actually try for a false statement. I'm going to graph this point and see if I get a false statement. If I do, then I have the right inequality. So is 0 greater than or equal to, this will come out as a 2 and become negative 2 plus 3, that's 1. Is 0 greater than or equal to 1? No, this is false. So I got the false statement I was hoping for, which means greater than or equal to is a solution. Probably simpler if you just would have picked a point up here and found out, hey, that's true with the greater than or equal to. Okay, now try this last one.